So LeetCode number 310, minimum height trees. We're given a connected graph and we need to convert it to a minimum height tree. So we have like a lot of ways to convert a graph to a tree like this. So these are the edges that are given to us, and these are all of the possible ways, or maybe some of the ways, to convert those edges to a tree. And what you want to do is you want to return the root label, so that if you set that value as your root node, your tree, the height of the tree is the minimum. And you could actually have up to 2 values that give you such a minimum tree. Like in this example, you have 2 possible roots that give you a depth of 2, right? Like here the depth is 2, and here the depth is 2 as well. So the key insight to solving this problem, which only comes by really good observation or experience, is that the height of the tree is basically determined by the longest path that you can take in the graph. So for example, in this graph, the longest walk, the longest path that I can take is like going from 2 or from 3 to 0, right? So if I wanted to have the smallest possible height, what I'd do is I'd set the root to be 1, so that half of the path is on the left and half of the path is on the right. Or like, it doesn't matter if it is in the left or the right, but it's like in a different branch. Because if I set it to like 2, then it's not perfect because I have the path being in the same branch. Like from 2 I go to 1, and then from 1 I go to 0, and that's just one branch, and it gives me all of the possible longest path. So I'm getting a height of 2. But if I'm smart about it and I take the middle point of the longest path in the graph that I can take, then by hanging the tree by that middle point of the longest path that you can take in the graph, then you've separated the biggest path into parts. And so your height is going to be smaller. So that's the key insight. So now we've changed the problem into finding the greatest path, the longest path that you can take in a graph. And actually, you can have also 2 values. So we're going to have to also handle that. So right now, I gave you the key insight, so I'll write down the code and then we'll walk through it again once more. So first of all, we just need to parse the edges. I always do that the same way in all of my videos. I'm basically using a default dictionary where the key is mapped to itself or an empty array, and then I add to that empty array or to whatever was there before the new neighbor, right? So after doing this, I now have my neighbors set up. And now what I need is a function that gets me the longest path starting from a certain node. And yeah, this visited is at the beginning is just an empty set, and I need this visited set to not have infinite recursion. So how to get the longest path? Well, what you do is basically just try all of the possibilities. So first of all, we're just visiting this node, so you add it to the visited set. Then what you do is you build all of the possible paths and you take the longest. So the paths are your neighbors or an empty array filtered by, you basically only want the neighbors that haven't been visited already. And then what you do is you map all of your neighbors to the longest path starting at that neighbor with the current visited set, right? And so that is going to give you all of the possible paths starting at your current node and going to all of the neighbors that haven't been visited yet. So these are all of the paths, and now you want to take the longest one. So you take the longest array in all of these paths, and that's going to give you the longest path starting from V. And now what you want to do is you want to add to the path your current node. And the reason for which you do this is just to have O of 1 insertion. And what this gives you is, since now we're going to return the path, like right now, we're going to return the path, pushing to the path the starting node at the end. Like imagine if this was the first call, it's like we're going to call this function starting with the 0th node, right? And so if you push the value 0 just before returning, like imagine this was the first call, this call right here, right? Then you're going to be pushing into an array that has already some values. So basically the last node in the path is going to be our starting node. And so that gives us that the last node in the longest path is now found at path of 0. Because if the last node in the path is the starting one, then the first node in the path is the last one, starting from V, right? So now we have one path that is the longest if I start from V, but that's not necessarily the longest globally in all of the graph. So to find the global biggest longest path, what you do is you call this function again, but this time starting from path of 0, right? So that's the last node in our biggest path, starting from the 0th node, right? And so this will actually give you the biggest path in the tree. And now what you need to do is you need to try to hang your graph, so to build a tree, by the midpoint of that path. And if the path has an even amount of nodes, then you're going to have two possible values that give you the same height. For example, here the longest path is 1, 2, 3, 4. So you have 4 nodes. So you have an even amount of nodes. So it doesn't make any difference if you hang it from 3 or from 4. You're still going to have a height of 2. But like in this example, where the maximum path is 3, right? You only have one element in the middle. And so you want to hang it from there, and you're going to have only one result. And so there's one cool way to find the two middle elements in a sequence. I mean, there's a cool way to find the midpoint in a sequence of values, no matter if the sequence is even or odd. And I'm going to show you that. But you could also just check if the length of, you could just do like, if length of the path is odd, then take the midpoint, and if it is even, then take the two midpoints. But here I have one liner that does it all. So I take the path length, and what I do is I slice the path by m minus 1 divided by 2. So this gives me one of the two elements, and then I slice it up to this, so m divided by 2, right? So for example, if I have a length of 4, I want 4 minus 1 is 3, divided by 2 is 1.5, and then I floor it. This is an easy way to floor a value. And so that would give me the first, the index 1, which is this. And then I also do m divided by 2, which is this, right? It's the node with index 2 in my path, and the path is this. So the node with index 1 is this one, and the node with index 2 is this one. However, you need to remember that slice is excluding the second parameter. So I add 1 to it, so then now I also have it. So like this is going to be 3, and so the node with index 3 is going to be excluded, and so I'll get the nodes with index 1 and 2, right? Or yeah, and if this one is too complicated, you can just do two conditionals. You can be like, if the path is even, has an even length, then take the two middle values. And if the path is odd, then just take one middle value. And now all that's left is to implement the longest array in function. So what that does is it takes an array of arrays and returns the longest array in that array of arrays. So we're just going to implement that real quick. So we have a maximum length, which is initialized with 0, and we have our current result, which we are later on going to return. And then what we do is we loop through all of the arrays, and if the current array's length is greater than the maximum length found so far, then we update the maximum, and we assign to the result the new candidate, because the new candidate has a better length. And then at the end, we just return the result. So yeah, that's it. I'm going to submit the solution to show you that it works. And I really, really enjoyed this problem because it has two very unique ways of solving it. One is this weird way where you call the same function twice to find the longest path globally. And the other solution is a very cool solution where you basically remove the leaves until you have only two values or less in your tree, right? So you recursively or iteratively remove leaves from the graph until you have only two nodes. Right, so that's going to be it for me today. Thank you for watching, and bye.